This is a LabVIEW Beginner Lesson Series, where we make a heart rate monitor. In this video, we'll separate the GUI and the processing functionality to two separate loops. We will then add communication between the GUI and the process. This is a two-way communication since the GUI sends down settings to the processing and processing sends up the process data to the GUI. We will start where we ended last time and just open Lesson 3 launcher. The goal is to get these controllers and indicators into its own loop, to give processing and the GUI its own loop so that it doesn't interfere with each other if there's any holdup in one of them. We're not that interested in the raw data here because we get the raw collected data, so just getting a piece of it, then we might as well just zoom there. The frequency is interesting, but we still get it here just multiplied, so we're not that interested in this either. We need something that sends these two values and this one up to the GUI and these from the GUI. Before we separate it, we can make the user event for every signal we want. So what we'll do is start by making constants of every data we want. There you go. We could copy these since all of these are waveforms, but we will not, because when we take control constant, we get the label we want on it. So let's just drag everything out here. There you go. We can make these ones smaller by just double clicking on them. There's no function in having it larger. The only difference is that you see the content. And we add one for each of these. And we can say we want the average length from the right. And there they are. So we'll just start placing them down. Now that we got everything in place, we want to get these to where they should go. There's a trick to making this easier. Rather than having 6 cables now, and it will probably be more later, we will collect them into one cluster, which will go to where they should. We will find a cluster. To get the constants we need, you can just right click here, create constant. And then we'll take the name from this one so that it's clear what it goes to. And we'll change it to auto sizing. When placing them in here, be careful to not put them over like this, because then you merge them, which is not what we want. And we will call it user events. Since we might use this other places and it might change later, we'll make it a type def just as we did with this one. When we add more user events later, it will update everywhere it goes. Make type def, open type def, and here is this, save. Now we need to find a new folder for this one. Since it's part of the init, we call it init. We call this one heart rate monitor dash init dash user events. We close this one. The names disappear as always. We just visible label and they're back. And then we find our bundle by name. And we start connecting. When you have all the user events into a cluster, you could actually just directly connect it like this. And as you see, this one updated and we have all of the user events. So if I choose add event case, I can see all the user events here. But this can get messy because then you don't know which event goes where. So what we will do is make a little bit more space here and then unbundle it. And we can do this multiple ways, but we could just say insert, cluster, and unbundle by name. And the one that was there from before was raw data. And we see now this one has kind of goofed up, so we just take edit event case and then we select the raw data user event. And we'll do the same with this one down here. It should now work as it did last time. You can see some things are deleted, so we'll just move things about and try it out. And we need to set this here. And we can see it responds to me tapping it. So it works just like normal. And then we can connect all of these. We can do the same as we always do, holding Control, press space, and then W. I'm gonna add another step which will not be clear before later, but if we do it later, there will be more of a hassle to doing it. Since this is the initiation part, there will probably be more data we'll send from initiation. What we will add is another cluster, which we call init cluster. Very good name. And inside of that, we will push this one. So I'll just pull it in for now. Here we go. Auto size, arrange vertically, same as last time. So now there's a cluster in a cluster alone without anything else, but it doesn't really matter because we will need to add something there later. And these ones automatically adapt to that. So it's under user event and the same with these ones. So now that we have that in order, we can copy this one. So what we'll do is just copy the whole thing here and push it up. We're not that interested in the middle part because we'll sort that out later, and all of these are just copies of the indicators and controls. So what we'll do is just delete it. We can then start moving stuff. We'll also make a cluster for the GUI, so the GUI has its own cluster. We don't need to make this type def, as for now, I don't see it being used inside any VI, so we'll just make a cluster that's not a type def. And inside of that too, we will copy this, not the init cluster, but the user event cluster. We're not really interested in all there, everything you see there. What we're interested in is just seeing the label. So both places we can just minimize this one and just say label. This is all the data the GUI will need to use throughout its runtime. So if there's anything else we need to add later, we'll add it into this. And by doing it like this, you don't need multiple shift registers. You just want one usually per loop. In the early lessons, we had 2, but then we had a lot of functionality crammed into one loop. But since we now separated it, we also want to separate the functionality. What I want is all the user events to be pushed into this one, and I also want the various user events here. Now this transfers all the user events to this loop here. So what we want into this user event, we want we're not going to receive this. This is what we're sending. We're going to send this one too, but the heart rate we want, and then we want the raw collected data, and we want the filtered data. If they don't show up like this, you can just click and select. We don't want the raw data. It's not so interesting for the same reason as I removed the graph here. And we'll do the same here, and we'll just connect them. Now we'll add these cases to the user event, add the event case, heart rate, sure. And from the heart rate, we will get to this one. So we'll just delete it from here, put it here. There you go. And there will be no error loop. So we'll just connect this one like this. A thing one can do is just to say link input tunnels and then create and wire unwired cases. Then it will auto make this one every time you make one new one. And then we'll add raw collected data. And you see, since we had the auto link, this happened. Because there's a danger if you don't have this and use default if unwired, and it's unwired, it will just get the default, which is a false, no error. So if there is an error, it won't be pushed around like I talked about earlier. So this is the raw collected data. So we will move this one up here. This might seem unnecessary now because they're in the same VI, so they didn't really change anything. Later, we'll encapsulate each module. The GUI will be into one VI, the process will be into one VI, and then the hardware acquisition will be into one VI. One can add these labels here if one wants to write what it is. So the GUI loop. So now the acquisition from this one is done. We can do the sending. So we'll need to make more events. But these events, we want to trigger when these change. So what we'll do, add event case. And then at the bottom, you can see all the controls and indicators. So we go with this one, samples, and then value change. Every time this control changes, like the value in it changes, this event will be triggered. So we'll move this one up here. This one is also good to take, create wired or unwired. So it's always connected. When we push this button, this case gets triggered and it reads the controller here and puts that in here and sends it on this user event. We don't have any receiving for this one yet, but we'll get to that. And we'll do the same for this. And to make it easier, we just duplicate the event case, select this control, and now this one was duplicated too, but we'll just delete this one, select the correct one here, and move this one. This one is a bit long. What one can do also is to hide the full name. Then it hides the top names of the clusters. This can be useful sometimes. We can also just move things around here. The next step will be to make it communicate with this one. Because right now, this one only receives the raw data and tries to do something with it, but it has no inputs here, so nothing would happen, and there's no output, so we wouldn't be able to view any of the data. We want this case to trigger when the raw data from here is sent up here, and not when these are changed. So we need another way to put in the samples and the additional signal to remove. What we'll do is to make a cluster for the process 2. Process data. And in here we want to add everything, even the raw data here, so we just have one nice thing in the shift register. We then need a way for this one to send in here, so we'll add a few user events. We can start by adding them here. We'll drag down 2, and we want the additional signal, and we want the samples. This is getting a bit long, so I'll just hide the full name. Now we can find this here. We'll just add event case. So that when this case here sends a signal, it triggers this one, it reads the data, because the data inputted here will come here, and it puts it into the cluster. So that when it uses it here, like reads from the cluster here, it gets the freshest data from here. And we need to do that again, so we'll just duplicate the case. So now we have all of the controls from here, the samples and additional signals to remove being sent to the processing loop. Now we need the raw and the filtered and the pulse to be sent up here. Set up 3 of these, since we need it for 3 different things. We need it for the filtered waveform, we need it for the pulse, and we need it for the raw collected data. Raw collected data is not strictly necessary, but sometimes when debugging, it could be nice to have. We also need to get the user event in here, so we'll just take a copy of this one, put it in here, and now this cluster contains the user event. We also need to transfer the user event to this loop, so we'll insert a bundle by name, because even though it's there, all the references in here are blank, so it's really important that we actually transfer all of the user events. We'll just hide the full names since it's not that important. Sometimes it's good to have the full name if there's a lot of similar names, but we know that these are user events since they directly go into a user event, which means it's not necessary here. The important with any code is really just that it's easy to learn or easy to look at and understand what's happening. That's the main goal. It's not to make it the smallest, it's not to make it look coolest. It's of course to make it work first and foremost, but secondly, even if you need to use like more lines of code or more VIs to explain it and make the code more intuitive, that's better than using less VIs and making it confusing. Because you could make it smaller by just hiding everything on top of each other. Wow, look at how great this looks. But it will be really hard for next person or you later to see, because if there's one constant in the universe, is that you will forget everything you know about your own code when you're done with it. And let's double check it's the correct raw collected data goes in there, and this is the raw collected data. The filter data goes in here, and this is a filter, and then the heart rate. So now we have ascending for all of these up here. So when each of these trigger, then they will go in here. We could have put them all into one user event and sent them together, but it makes it less flexible if we want other parts of the application to receive the same data. And then lastly, we need to close all the user events, which we have done like here. We will not do that here. We will think that that is the GUI task, so we'll move it from here, because we want to do it one place, and then we can say error out process, and we'll add it. So we have 6 now, so we'll just add 6, 1, 2, 3, 5, 6. We will use LabVIEW's tools to the best of our knowledge, and there you go. And now the error will come from here. We'll unbundle here. Since this is where all the controls and indicators are, we should move this one too. So what we'll do is just move this here and then copy this one. If you press it, Control C, Control V, you will get up a new stop button like this. So what you need to do is select it, hold Control, and then drag it to copy it. You could also have right-clicked here and create another local variable, but that's too much of a hassle. Now this is the final control here. Oh, but this is the wrong event. So what we'll do is we'll create a new event, add an event case, stop, and then when the stop button is pressed, it will go into this event. This is starting to get messy, but it will be cleaned up in another lesson. Let's see what we've done. We have made more user events, collected them in a cluster, shared them where they should be, and then we close them here. And then we have set up the receiving of the important data in here, and the same here, and we also have the sending of data. This is a remnant of the old. Let's delete it, delete this case. Let's test it out now. Funnily enough, we have really not changed anything to the acquisition of the pulse meter, so hopefully everything is the same. What we see now is that even though it says 10 here, it doesn't update here because this only sends the data when it's updated. So if we say write 11 now, press enter, it sends it down and now it can start collecting. Earlier, it would just read this data and continue, but now the default data is 0, so it doesn't know where to start. And we see it works as normal, and we can stop it. We see that it didn't actually stop, so we have an issue here that something is running. We did something wrong. And by pressing this one, we can see what's still running. What we see is that this one is still running, and these two have stopped. This is because it only goes into this event when this one sends data, and if this one closes before it reads this one, it will not stop. It will just wait for new data here. What we need to do is to stop it like this and then move this one outside of this loop. We also need to add a timeout so that if nothing happens, it just goes through the loop and reads this indicator. Because if we only have this one and no timeout, it will just stop here. We need to add a timeout event, add event, this application, timeout. This is the one we deleted earlier. And there you have it. So if nothing happens in 500 milliseconds or a half a second, it will go through all of this and among things read this one. So we'll try that again. Remember to turn off the debugging or this will take forever. We press play, change to 0. And here it goes. So we are not interested in the date now. We'll just stop it. And we see it stopped. It had a little delay with the stopping. And that was because it takes a half a second to check. This error here, this one errors out because before it can read this one, this guy has already ended, gone into here, closed the user event. And when this one tries to send with this user event, it doesn't find the reference because it's closed and it errors. So it goes in here and does a stopping through there. This is not a problem because it stops because we wanted it to stop. Later, I'll show a solution so it actually stops from the signal and not from an error. As you noticed, we need to change this one for it to start. One thing we can do to just have a default value here is just to say data operation, make current value default, and add 10 here. So the default value in here is 10. So when it gets the raw data, it starts at 10. So if we start it now, we see that it can start without us changing this one. And this can be nice. The only problem with doing it like this is that these 10 numbers is not connected in any way, except that we just selected 10 on both of them. It would be better to have a common configuration we set them both, but it's frankly not necessary for this application. So that's it for this lesson. We have now put the GUI and processing in different loops. We have set up different user events, making it possible for them to communicate even though they're running in parallel. And this will make it easier for the next lessons. In the next lesson, we will compartmentalize the processing loop.